Hello dear students, I am Vijay Subha. Welcome to my YouTube channels. Today we will discuss what do all acids and all bases have in common. If you like my video, then please like it, share it and subscribe it. And also if you want to see my previous video, then you can go through the description link given there. Now we will continue our topic. What do all acids and all bases have in common? So in section 2.1, that is, we have seen that all acids have similar chemical properties as well as bases also have similar chemical properties. Again in activity 2.3, that is, acids generate hydrogen gas on reacting with metal, isn't it? So hydrogen gas seems to be common to all acids. So actually this is your activity 2.1, that is, so in this activity we have shows that all acids when tested with red litmus paper then no color changes, but when all acids tested with blue litmus paper then the blue litmus turn to red, isn't it? Again when all bases are tested with red litmus paper then red litmus turn to blue. Phenolphthalein when tested acid then no color change, but methyl orange when tested with acid then color of acid will turn to red. But phenolphthalein when added to the base then change in pink in color. Again methyl orange added to base then this turn yellow in color. Also when acids react with hydrogen acids react with metal zinc granules, then hydrogen gas is produced by producing pop sound, isn't it? So now we are moved to this. So it is written here, all acids have common what? Hydrogen gases. So because of the hydrogen gases, they shows the similar chemical properties. So to understand this, whether all compounds they are containing hydrogen may be acids or not. Okay, so let us perform an activity. Investigate whether all compounds containing hydrogen are acids. So to do this activity, activity 2.8 is given in your textbooks. To do this activities, it is shown here the apparatus like that. To do this activity, we have to take to iron nail a plastic or rubber cork, a small 100 ml beaker, wires, a 6-volt battery should be needed, a bulb and switch should be needed, so that they are fitted in like that. Okay. In the iron nail fitted with the cork should be inserted in the 100 ml beaker. After that, the two ends of the iron nail should be connected with the circuit. Now we are filled with acids. Okay, first HCl, and when we apply the switch, then we'll observe here that this bulb will glow. Okay, when we change under acids, nitric acid HNO3, then also it is found that the bulb will glow. Again, hydrogen containing compounds, another, suppose glucose formula is H2, sorry, not H2, C6H12O6. this is the glucose formula. So when we add it here, after then when we apply switch, then it is found that the bulb will not glow. Again, when we added another solution, hydrogen containing compound, example alcohol, ethanol, CH3CH2OH, so it also contain hydrogen, but when we added alcohol here and applying switch, then it is also found that the bulb does not glow. Okay, so actually what is happening here, when acids applied and after applying acids, when we give switch, then actually acids will HCl acids or HNO3 or H2SO4, okay, they will break into ions, H plus plus Cl minus. These H plus ions will carry the current in the circuit and makes the bulb glow. Okay, so it is written here, the bulb will start glowing in the case of acids as shown in the figure 2.3, but you will observe that the glucose and alcohol solution do not contain conduct electricity. So why the glucose and alcohol does not conduct electricity? Because glucose C6H12O6 they does not form into ions, they does not break into ions. Okay, when they dissolve in water or dissolve in any liquid solvent, they will be dissolved, completely dissolved, but they does not break into ions. So glowing of bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. Okay, since the cation present in the acids H plus ion, this suggested that acids produce hydrogen ion. H plus AQ means in aqueous form, in solution, which are responsible for their acidic property. So if we talk HCl, I have shown earlier, H plus Cl minus. So this H plus ion indicate the presence of this hydrogen ion, shows that acidic character. Same activity when we repeat with bases, calcium hydroxide or sodium hydroxides. Okay, then also when we added the bases in place of this, okay, bases NaOH, and then also the bulb will be glow after applying switches. Why? Because sodium hydroxide base also break into ions. NaOH when applying break into Na plus OH minus ion. So base contain OH minus ion. This is known as hydroxide ion. So OH minus aqueous ion in water. Okay. Next, what happened to an acid or a base in a water solution? So acid and bases when dissolved or in water solution, then it will produce ions. Okay. So to do this activity 2.9 is given. So you have to fit like that apparatus. In this apparatus you have to need test tube and a delivery tube. Okay. In this test tube you have to take 1 gram of solid sodium chloride in a clean dry test tube, and after that you have to add some sulfuric acid and close the mouth and observe the gas coming out, and take 2 litmus paper, dry and wet litmus paper. Okay, so when the gases come out, the reaction between this sodium chloride and sulfuric acids. So here the reaction between the sodium chloride and sulfuric acid, they will produce like that. Sodium chloride and sulfuric, they produce hydrochloric gas, hydrogen chloride or hydrochloric gas, and sodium salt. Okay, sodium sulfate salt. So this hydrochloric acid is actually dry gases when come out. So when we test with dry blue litmus paper, then it is found that the color of the litmus paper does not change. But when we take a wet litmus paper or moist litmus paper, then it is found that blue color litmus paper change to red. Okay. So actually in the wet litmus paper, the litmus paper changes to red. This is because actually it is written here, the experiment suggests that the hydrogen ions in HCl are produced in the presence of water. So in the moist or the wet litmus paper, there is water content. So due to the water, this hydrochloric acid break ions into ions. Okay, H plus ions from HCl molecules. Okay, but cannot occur H plus ion in absence of water. That means that's why in the dry litmus paper, the color of litmus paper does not changes. So the reaction shows that HCl plus H2O, then H3O plus Cl. Actually H3O plus ion is why it's happening. It is written here. Okay, hydrogen ions cannot exist alone. So when hydrochloric acid react mix with water, then they will form H plus ion, that is hydrogen ion. These ions does not exist for longer time. They will directly combine with water molecule. Okay, it is written here, water molecule, then they will form H3O plus. It is called hydronium ion. Thus hydrogen ion must always be source and H plus aqueous ion or hydronium ion. Why? Because H plus ion is very reactive, and they will combine with water to form hydronium ion. We have seen that the acid gives H3O plus ions or H plus aqueous ion in water. So let us see what happens when a base is dissolved in water. So actually when base is dissolved in water, then they will form OH minus ion. Okay, this is also in aqueous form. So there are some different reactions are in potassium hydroxide in water, then K plus OH aqueous minus ion, magnesium hydroxide, then also magnesium ion plus 2 OH minus ion. So base generated hydroxide OH minus ion in water. So base which are soluble in water are called alkalis. So some bases are completely soluble in water, dissolve in water, or dissociate, break in water, but some bases are slowly or very lessly dissolved in water. Okay, so it is written here, all bases do not dissolve in water. All an alkali is a base that dissolve in water. They are soapy to touch, bitter and corrosive. Corrosive means very reactive, okay, and bitter, and touch and then it feels soapy. So they are called alkalis. So never test or touch them as they may cause harm. Okay, alkalis should not be touched because they causes harm. So next here look, now as we have identified that all acids generated H plus aqueous and all bases generated OH minus aqueous can be viewed and neutralization reaction as follows. Acid plus base gives salt plus water. So acid means H, hydrogen is there, and X means any, it may be halogen, chlorine, fluorine, bromine. Okay, M means metal, OH. So they will form what? H plus and OH minus, then it will form water and salt. Next, dilution of the acid. So it's written here, let us see what is involved when water is mixed with an acid or a base. So to understand this, activity 2.10 is 10 is given. So here you have to take 10 ml water in a beaker. In a beaker we have taken water 10 ml and a few drop of concentrated sulfuric acids with stirring. Okay, slowly in the beaker. Then when we touch the beaker, then you will find that in the bottom of the beaker it will become very hot. Okay, so this reaction is known as exothermic because when we mix acid in water, then it will produce heat is generated. Okay, again in bases also, sodium hydroxide, when we added water, then it also produce heat. So that is exothermic reactions. Okay, so the process of mixing acid or bases in water is like that. Written here, the process of dissolving an acid or a bases in water is a highly exothermic one. Care must be taken while mixing the concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to the concentration acid, the heat generated may cause the mixture to splash out and cause burn. Okay, the glass container may also break due to the excessive local heat. So when we mix water in acid, then first you have to take a little acid in the beaker, then after that you have to add water drop by drop, and you have to stirring with a stirrer, constant stirring, then you have to mix. Otherwise, if you add acid in water, then if there's water and add acid, then it will produce a heat, okay, local heat, and it may be cause accident. Okay, the glass or the beaker may be get damages, break out. So this is the process of mixing acid and bases. Okay, so what is happening when we added water, okay, or when we add acid in water? So it's also written here, the glass container may also break out. Oh yes, we have read it. Local look out the warning sign that is in the figure 2.5. This sign actually labeled in the bottle of this sodium hydroxide as well as sulfuric acid, hydrochloric acid. There where there's concentrated acid, this label should be given. That is caution label. Okay, so mixing an acid or bases with water results the decrease in concentration of H3O plus or OH minus per unit volume. Such a process called dilution, and the acids or the base is said to be diluted. So diluted means, dilution means, example, you are taking this amount of acid. Okay, this is HCl, suppose concentrated HCl. So here H plus ion is per volume, suppose it is 2 ml per volume, or liquid per volume of HCl H plus is more here. If we add water, isn't it? In suppose we have add here 5 ml of water, okay, 5 ml of water, and if we add this 2 ml of acid mix here, then the concentration H plus ion will be less per this volume. The volume is 5 ml, isn't it? When we added 2 ml, total will be 7 ml, but the amount of H plus ion should be less per volume. So that's why the strength of acid will be decreases. Okay, like that base also, when added to water, then the amount per volume of OH ion will be decreases, then the base should be diluted. Okay, that's all for today. Thank you.